Hello, and welcome to another lecture in CIT 130. Now that we've learned the basics of Java development, how we design and order our files, and what the elements that make up a file are, we can get on to some real programming. I'm assuming that all students at this point are at least have been exposed to decision statements, statements that involve choices based on the value of specific variables within an application, what we would normally call if or if then statements. We're going to look at those specifically in Java, and I'm going to introduce the topic by creating an example that's a fairly simple, practical example. I'm going to show the basic syntax and show how we have to be careful with the way that we design our application. And then after we see what can happen if we're not careful, we'll look at a series of ways of correcting issues that help us understand the various ways in which we can use decision statements to make choices within an application. So I'm going to start, as we have in every example so far this semester, and we're going to create a new class. We're going to call it public class movie tickets. This is going to be a very simple application that is going to ask the user to put in the number or the age of the person coming to the movie, and then we'll decide how much that person's ticket costs. So we begin our main method as usual, public static void main string args. Because we're going to be doing keyboard input, we have to use the import statement. You would have seen this in the last video, the lecture 2.1. We use java.util.scanner for doing keyboard input. We create a scanner object or scanner variable that we name keyboard, and we create it by doing new scanner system.in. Again, watch lecture 2.1 if you need a little more information on this part of the application. So what we're going to do is we're going to write a message or prompt out to the user where we're going to say, please enter the age of the person. We'll go ahead, and then we are going to have to take that age and put it into a variable. One of the things that's a good habit to get into is declaring all of your variables at the top of the main method. So what I'm going to do is make a variable called age that is of the integer type. And then within the body of the application, we'll go ahead and say age equals keyboard dot next int. That will allow us to pull that integer off of the keyboard, and we'll use it to with our decision statement. So now let's look at the syntax, the format for the decision statement. In Java, we use the if reserved word to create a statement that makes a decision. It's followed by the parentheses because the if statement works very much like a header, like it does in the main method or the public class declaration above. So what we're going to say is we're going to say if age is less than 12, that's our child ticket. We'll say that price equals $5.50. Now I didn't declare the price variable yet, so let's go up back to the top. Again, it's better to do all our variables at the top. The reason for this is that in large programs that you'll get to as you expand your experience in working with programming and in Java, it's better to be able to make changes or know what our different variables and constants and objects are at the top. We can make the changes at the beginning and they'll propagate throughout the program. So we'll do double price. Now the other special case is a senior citizen. So we might say if age is greater than or equal to 55, that's what we're going to call a senior citizen. They'll have their own special price, which will be 6.5. For everyone else, which is people who are over the age of 12, greater than or equal to 12, we will have the standard price for the film be $7.50. Now you can put the 0 on the end if you're more comfortable with that because that's the way you envision it, but it's not necessary. Any zeros that lead on the left are not significant, just like after a decimal point any on the right are not significant. That's a matter of preference and style. I go ahead and leave it truncated. In a couple of weeks, we're going to talk about how we can use special formatting in our printing to add extra digits if those are necessary for proper look and formatting. So now that it's evaluated the decision statement, we will do system.out.println the ticket costs $, $, plus for concatenation price. Now, whether we put the 0 on the end of these or not, in this current version here, we won't get that 0. If we want, since we know all of these get the extra 0, we could tack it on as sort of a string, because we know it's going to print out 5.5, it's going to print out 6.5, or it's going to print out 7.5. So we can throw that little 0 on the end there. Again, in an upcoming lecture, we'll talk about formatted printing, where we can really do some nice custom printing of different data types. Now, just to go back and look at the decision statement part one more time, we have these 3 different if statements. They evaluate against the value of the age variable, which gets set by the user in the line here. So if the age is less than 12, their price is $5.50. if age is greater than or equal to 55, their price will be $6.50. If the age is greater than or equal to 12, their price will be $7.50. Now note that what goes inside these parentheses is something that is either true or false. This introduces a new idea. This is when we kind of talked about our data types. One of the things we talked about were Boolean data types. Boolean data types are types that that hold a value of true or false. Sometimes when we evaluate statements using comparative operators, that's what we call things like the less than, the greater than or equal to, and later we'll get into equivalence or equal to. This evaluates to a Boolean value. So age is less than 12 is either true or it's false. Age is greater than 55, greater than or equal to 55 is true or false. And age is greater than or equal to 12 is true or false. So that's how those evaluate. We'll talk a little bit more about truth values, Boolean values, as we move through this exercise. But let's look at the simple version here first. So what we're going to do is we're going to go ahead and save this. In this class, we're in CIT 130, and we'll put it in the examples, and we called it movietickets.java. Let's go ahead and compile that. Java C movietickets.java. We start by getting an error. Before I fix the error, let's talk a little bit, because this is something we haven't looked at yet, at understanding errors that come back when we compile programs. This is something you'll gain experience with as you work with your own applications and make your own programs. So you'll see it names the source code file that's involved. Sometimes we can compile more than one file at a time. So in this case, it does want to make sure it lets you know which file it was in. The next thing after the colon here is the line number on which the error occurs. If you see back over here, it's referring to line number 27. Then it displays what has happened. It's an error, and that error tells us the variable named price might not have been initialized. What that means is that when we get to this point, price may or may not have a value. Now that may seem odd to you at first, because we know at the very least from our own logic that any number, and age is a number, we made it an int, any number would be either less than 12 or greater than or equal to 12. That's just a true thing. But that's not how the compiler analyzes this. The compiler isn't smart. It's simply consistent. And what it does is it knows that everything inside parentheses that accompanies an if can be true or false. So age is less than 12 might be false. Age is greater than 55, greater than or equal to 55, might be false. Age is greater than or equal to 12 might be false. Since each one of these might be false, it surmises that price may not be any of these values. The typical way of dealing with that in an instance like we've seen here is we initialize the variable at the declaration time, and we can make it 0.0. Again, because we understand the logic and the mathematics here, we know that we're going to never print out 0 as an answer, because the if statements cover every possible value. But it's an interesting thing just to be aware of. We're going to do some other work down here in the decision statement section of the application. And when we do those things, we'll look at other ways of preventing this initialization problem. So I resave. We can go ahead and compile it again. I got no messages back. That means that it worked properly. So now it has compiled. So we invoke the virtual machine with the application. Remember, we don't put the dot class there. We're invoking the virtual machine with a class name, not with a class file. When we do that, it should ask me to enter the age of a person. So let's say we're taking a young child and they're 5 years old. We should expect this to print out and tell us that the movie ticket price is $5.50. Perfect. It worked properly, and we were able to get the answer we wanted. Let's now look at our second case, a senior citizen. Let's look at somebody who is 77. And here we would expect the cost to be $6.50. So let's go ahead and hit return and see what we get. What we get is the wrong answer. So what we call this is a logic error. This is a problem in the way we wrote our program. The program works, but it doesn't give the right answer in some cases. Now, if I go to a regular adult, say 49, we expect $7.50 and we get $7.50. So it seems as though the senior citizen price is messed up. The reason that is in the way this is written, we evaluate this if statement. Is 77 is 77 less than 12? No, it is not. If this evaluates to false, everything written between the two curly brackets does not execute. It simply drops down to the next thing after the block. It says if age is greater than or equal to 55. Is 77 greater than or equal to 55? Yes, it is. If what's in the parentheses evaluates to true, it goes into the curly brackets and does what's in here. It now changes price from 0.0 to 6.5. Once it's done, it goes to the next piece of code, and it says if age is greater than or equal to 12. Is 77 greater than or equal to 12? It is. So it changes the price from $6.50 to $7.50. Once it does that, it drops out and performs this printout which is going to print out the 750 score. So for a minute, the senior gets their discount, but they don't keep it. Now, I introduced that logic error on purpose because it provides a really good opportunity for me to show several ways to fix this issue. The first of these is to reorder the ifs. If I take the greater than or equal to 55 and drop it below, now anything that's less than 12 is going to produce the 550. If it's 12 or older, it gets the 750. But if then it is also greater than or equal to 55, it changes it from 750 to the 650, which is the correct behavior. It does temporarily store the wrong answer, but ultimately fixes that and stores the right answer. And we'll be able to see by recompiling and rerunning that that is true. We recompile. We run. Now, one of the things that I recommend when doing testing of your application is look at significant data. Anything that's less than 12 should give us the 550. So we could pick something random, like I did before. I think I used 7. That gives me the 550. I know it works. One of the things that's important or valuable to do is test with what we call edge values. The values that live in these places are important because one of the things that can happen is if I had this less than or equal to 12 there, and then this one to be greater than or equal to, just greater than 12, the number 12 itself isn't captured there. So what would happen is with the number 12, the price would stay 0. That would be a problem. We do want it to be greater than or equal to 12, and we want that to produce an adult price ticket. So it's good to test that edge value. So let's put in 12. It comes out with the 750. I'll just go ahead and put in another random one like I did before just to make sure it seems consistent. And now we've reached the senior citizen one. So what I would recommend is try the edge value. 55 is a senior citizen, so should we get the 650? Perfect. And then we can try again with something higher, like if the person was 77, the 650. Everything checks out. So that's one way to solve this problem. This way is probably the least commonly used because from a logic standpoint, one of the things that we've done here is we've taken a number when they are a senior citizen and we temporarily assign the wrong answer before assigning the right answer. Now, in order to fully show that this next solution solves the problem, I want to go back to the order that messed us up, because there's another way to fix it without rearranging them, and that is through a new keyword called else. When we add the word else in front of if, what we've now done is we've linked these three if statements together. What it's really doing now is it is finding the first match, and if it matches, instead of simply going past the block, it goes past all the else's and simply prints it out. So in this case, when we have the 77 or the 55, it'll set the price as 650, but it won't recheck it here because once it found the true statement, it drops to the end of the linked decision statements, and they're linked through the else. So if this is true, do this. Otherwise, or else, do this. Otherwise, or else, do this. So it's in that funky order that I started with, but I still should get the right answer because once it finds the first solution that matches or yields a true, it drops down below the last else statement. And we can see that in action by going ahead and recompiling. We can run it for our regular ones we've been doing, the 7, the edge value 12, some in the middle 750, the edge value for a senior citizen, and then another value for a senior citizen. Whoops. That was an accident. I recompiled. 77. And we get all the right answers. Now, one of the things that we have with this new keyword else is we can sort of have a default or final case here. If I say else price equals 0.0, remember, like I said, if there are else's, as soon as it finds one in that grouping, it immediately doesn't do any of the other tests. So if the number isn't less than 12 and it isn't greater than or equal to 55 and it isn't greater than or equal to 12, we would get a price of 0.0. If we do it that way, we don't need to initialize up here. We can remove that initialization because no matter how many of these first three statements are false, there's a catch-all. Anything else yields a 0.0. And from a training perspective, if you were having somebody from, the movie theater work on this and you train them, you would basically say if the price comes up as a 0, something didn't go right, so call over the manager or whatever, however you wanted to do that. But it allows us to declare the variable at the top and not have to initialize it. There are some people who still prefer to initialize variables, but it's absolutely unnecessary if we have a statement like this. Let's compile. And we should wind up with the same results. Oops, I keep doing that. We did the 12. Let's do 49. That should be the 750. Let's do the 55. That should be a senior rate. And let's do 77, also a senior rate. So we're getting all the right answers now. But we did it by linking all of these statements together. Because ultimately, we want to set the price based on the value of the age that the customer tells or proves to the box office worker. Again, our own logic tells us this will never happen, but this statement helps appease the operating system because it's no longer buzzing to get you to add something that was already there like we were getting before. So there's another way to solve this problem. And this is what we call a nested if. What I can do here is I can say if age is greater than or equal to 12, then we do this. If age is greater than or equal to 55, we already know it's greater than 12, but it may or may not be greater than or equal to 55. We can do that, and then we can say else price is $7.50. Now, one of the things that is true inside of any header block-based elements within a Java program, where we have a header and then the opening bracket, some code followed by the closing bracket, is if there's only one line of actual code, what we can do is we can get rid of the brackets, because the compiler will then assume only the next line is associated with if the item is true or not. And I'll just show you, along with showing you that this solution works, that that is true. Let's go ahead and compile it. We run it for 7. Oh. I forgot to remove this. By forgetting to remove this, what I did is I associated this else with just this. So what happened was it set it to 550, came over here, it wasn't greater than 12, so it put that there. I meant to get rid of that because that was part of the previous solution. But when I do get rid of that, I do have to initialize again, or we'll get the compiler griping at us. Let's compile it. Now it'll be correct. We'll do it with 7. We get the 550. We do it with 12. Shoot. We do it with 12. We should get the 750. If we do it with 49, we should get the 750. If we do it with 55, we should get the 650. If we do it with 77, we should get the 650. So again, the solution works. Now, within the nested, I can also still use the else if, and then I can do the else price equals 0.0 and get rid of the initialization, because whenever you have an else, it's always paired to all of the previous else's up to the first if without an else. So before, that else was going to this if because it didn't have an else on it. But now all 3 are linked, so this is a valid way of doing it. Compile it, show again. I'll just show you that the 7 works in that way. I'm not going to go through them all I think you're following um, what we're doing here. Now, real quick, I'm going to go back just for a second. And I'm going to talk again about this idea of whether we do or don't put these brackets in there. You will see a lot of developers, a lot of programmers, when there's only one line, leave the brackets out. You will notice going forward that it's very rare for me not to put them. The reason I put them even when I don't need them is experience has shown me that a lot of times when only one thing happens when the case is true, that later on as you expand what the application does, you may wind up doing something else when it's true as well, and you may forget to put the brackets in if they weren't there to begin with, and you've gotten yourself in the habit of not always putting them. And then what will happen is the second operation that's supposed to be linked with the true expression in the if statement happens every time, whether it's true or false. So you will notice that I will put the brackets in there because I think it's a better practice, and it's safer in the long run. So let's look at one more way to fix this. It's going to expand a little bit on what we're doing. You know, we've learned about the if statement. We've learned about the else reserved word. We learned about these comparison operators: less than, greater than, or equal. But there's also something called a logical operator. So a logical operator is one that allows us to do multiple comparisons and evaluate it to one truth value. So let me explain what I mean here. So the first one we have is the double ampersand. The ampersand is what you get when you hold down the shift key and hit the 7 on your number row. This is logical and. How does logical and work? Logical and it evaluates in a way that only if both operands are true is the expression true. So if we say x and y, this is only true if x is true and y is true. There's a thing called a truth table that we use with Boolean logic. And for an AND operator, how that looks is we have true, false, true, false. And what we do is If the left and the right are true, it's true. If the left is true and the right is false, it's false. If the left is false and the right is true, it's false. If the left is false and the right is false, it's false. Now, the plain English way that this works kind of makes sense. If we do, if we said something like, I am going to go to the store and to get gas, then you are expecting that I am doing both things. I am going to the store and I'm getting gas. That's how logical and works intellectually in our everyday language. When we use and in that manner, we are indicating that both things are going to happen. If I say I'm going to go to the store and I'm going to get gas and I have no intention of going to the store, then I'm lying. So I'm going to the store is false. So the whole statement is false. We'll see this in our example and then in more examples throughout the class. So just hold on to that idea for now, and we'll move through it as we continue working on things throughout this semester. Logical OR is done with pipe. So the ampersand is a symbol you've probably seen before. This vertical line, which we pronounce pipe, is a symbol you may not be as familiar with. Generally, on the far right end of your keyboard, there is a left-leaning slash key that when you hold down the shift and hit it, you get this bar-like symbol that's called a pipe. On some keyboards, it will show a little white space in the middle of the line. That is only for the keyboard to make sure people don't confuse it with L or 1, but it will always display on the screen as this pipe. Up here, I used it as a separator. Down here, when we do it, two of them together, what we've done is we've created a logical OR. A logical OR says if either operand is true, then the expression is true. So if I say X or Y, this is true if X is true, if Y is true, or if X and Y are true. This also has a truth table. True, false, true, false. When the left operand and the right operand are true, both of them are true, it's true. When the left operand is true and the right operand is false, it's true. When the left operand is false and the right operand is true, it's true. But when the left operand and the right operand are false, it's false. So what we would do here, again, if we're speaking in terms of the sort of English language equivalent, the common sense way of looking at this is if I say, I'm going to go to the store or I'm going to go to get gas, someone, if you went and just got gas, you didn't really lie. You said, I'm going to go do this or I'm going to go do that. If I went to the store and I didn't get gas, again, nobody would think I was lying because I said I was going to do one or I was going to do the other. Now, in speaking English, what I just said, there's only one kind of or. What we call this logical or is the kind of or where if I say I'm going to go to the store or I'm going to go get gas, if I do both, I didn't lie either. I indicated one or the other, but the truth is, I'm still not lying if I said both. There is an additional operator, which is the caret, gotten by holding down Shift and hitting the 6 key. This is what we call exclusive or. Exclusive or is the kind of or where it's only true if either is true, but not if both are true. The kind where if I said I'm going to go to the store or I'm going to get gas, where you interpret the or as being exclusive, or that I'm really only going to do one of those two things. If I do both, then I misled you. Again, in spoken English, there's no differentiation between the two kinds of or, but in formal logic, which is actually a philosophical pursuit, we differentiate. And so in most programming languages, there are two different operators for standard logical or and exclusive or. So in this case, the truth table looks like true and true is false. True or true is false. True or false is true. False or true is true. False or false is false. This is exclusive or. So in English, I would say the same thing. I'm going to the store or I'm going to get gas. Whether I mean I might do both or I really mean just one or the other. But in computing, we don't want that ambiguity, so we use two different operators. There is one more logical operator, which is the exclamation point, often pronounced as bang. This is what we call logical not. When we use logical not, we essentially flip the truth value of the operand. Logical not is a unary operator. We're used to binary operators where there's a left operand and a right operand. 1 plus 2 makes 3. Age is less than 12 makes true or false depending on age. True and false makes false. But in this case, it's a unary operator, so what it does is it flips the truth value of the operand, because there's only one. So not x and that's how we read that, not x. This is true if x is false. This is false if x is true. We use a slightly different truth table here. Whoops. What we say is we say when it's true, it becomes false. When it's false, it becomes true. That's how it works because there's only one operand. We flip it. So let's look a little bit at this. Let's go back to our movie ticket example. And let's make it more concrete. So the case of age is less than 12, then we have the price of $5.50. That we don't have to change. But what I might do here is I might say if age is greater than 12, then we're going to get rid of the nesting here. Give me a second. Now, one of the things you'll notice, this is somewhat of an aside, is that I'm doing a certain indentation here. When I have these sets of opening and closing brackets in a line with each other, everything between them I gave a single tab indentation for. What that does is visually puts everything here inside of the block that says public class movie tickets. The definition of the class, the program, is held between the opening and closing brackets. We call it a block. We talked about that a couple of times ago. And likewise, everything between here and here, this stuff defines the code for the main method. So it's indented. Likewise, when we get down to an if statement, that if statement has the brackets, so we indent inside there so that everything in here is what happens if this expression evaluates to true. That is a visual cue only. Going back to when I get rid of, the brackets, the simple indentation, if I put something else here, like price equals, $5.75. This second line, even though it's indented, will execute whether or not age is less than 12. The indentation isn't what makes it go with the header. It's either the next line, the 5.5, or everything contained within the curly brackets. That's why what I was saying before, I go ahead and put the curly brackets in anyway. The extra couple of bytes does not fill up my hard drive, so I'm not concerned about it. So just kind of wanted to mention that. So we got rid of the the one for senior citizens, but again, going back to the one where they're out of order, where that caused us a problem, equals 650. If we say down here now, if age is greater than 12 and age is less than 55, then price equals 750. Now what we've done is we've cured our problem, because when we had age is greater than or equal to 55 and age is greater than 12, anything that's greater than 55 is also greater than 12. So that's why we were getting the 750. But now when I throw in this and, what's going to happen is if we take 12, our edge value, 12 is greater than or equal to 12, true. 12 is less than 55, true. Therefore, it's true. But if I take 55, another edge value, 55 is greater than or equal to 12, true, and 55 is less than 55, false. Remember, our truth table says true and false, true and false is false. True and false is false. So this one won't fire if this one's true. Remember, be careful with your edge values. If this is greater than or equal to, make this one less than. If this one's less than or equal to, make this one greater than. Two things to be careful is don't put the equals on both, because then now 55 is confused. Is it a senior citizen or isn't it? And if you leave the equals off of either, then 55 is even more confused, because it's not even a valid value at that point. It holds no value, and it goes back to our initialized version, the 0. And that's not the right way. The right way to go about it. So this way, that logical and tests it out. Now everything is mutually exclusive because of my logical operator. And we'll get the right answer here. So let's go back. We'll recompile. Seven gives me the correct answer. 12, adult price. 49, adult price. 50, whoops, did it again. 55, senior citizen price. 77, senior citizen price. It all works. To explore this idea of the logical operator a little further, Let's say that we decide that senior citizens are going to start getting the same price as kids. Now what we could do is we could say if age is less than 12 or age is greater than or equal to 55, then price is $5.50. So when we do that, now senior citizens are going to get the 55 and the same price as 12 and under. 55 and over is going to be the same as under 12. Let's see that by again recompiling, rerunning. 7 is $5.50. 12 is $7.50. 49 should be $7.50. 55 should now be $5.50. 77 should be $5.50. One of the things that may wind up being a bit of a challenge for you when you're first working with these logical operators, and you're going to get a chance in the second homework, is getting your ors and ands mixed up. That's the good thing about testing this stuff, is when I test the application, if I don't get the results I want from the logical operator, just stop and think about it, or try swapping your or to your and. Those are ways to figure out why it might not be working. I know the things like the truth tables seem kind of weird, but if you really think about it without, being overly intellectual, you can just look at it. If the left is true and the right is true, it's true. If the left is true and the right is false, it's false. You can actually look and say, given any value, what's on the left, what's on the right, and you'll know which way to go. Now, for the example we're doing right now, there's technically no number that would kind of fit in both these categories. So we don't have an example that's going to work with exclusive or right now. For the short term, just concentrate on logical or and logical and. That's what you're going to get to practice in homework 2. And those are the most common ones we use. We will start using particularly the not, the logical not operator, the unary operator, more in the future. And we'll see exclusive or in the future. For now, just focus on these, and we'll look at the others at another time. So now I want to look at a couple other ways of doing this. And it's something we're going to see more than once. But there are actually 2 other ways to do decision statements. The if, or the if-else sort of construct we've been looking at so far, will work for everything. It will work for everything. But there are 2 other ways of doing decision statements. One is called a switch statement. Now, for things that work in a range like this, a switch statement isn't as valuable. It's used much more in an equality sense when one value equals another. So I'm going to save showing the switch statement for another lecture. We will, but there's another kind of cool shorthand that we can use in place of the if else if the if else uh, place, and we call that the trinary operator. Binary operators have a left and a right. Unary operator, like the not, just has one operand. The trinary operand has a left, a middle, and a right, and two operators, but it all goes together. If this part is confusing, you do not need to know it. You can do everything with if, else kinds of statements. But what I'm going to do here is I'm going to replace this with something. Actually, I'm going to leave that for now. But what I'm going to do is I'm going to comment it out. I'm going to put it in a comment so it's not part of the program, but so that you can still see it. What I can do is I can say price equals. So the result of these if blocks of statements is a value for price. So, but I'm going to do a specific evaluation. I'm going to say age less than 12 or age greater than or equal to 55, question mark, 5.5, colon, 7.5. What this means is if age is less than 12 or age is greater than or equal to 55, then assign this number to price. Else, assign this number to price. Because, and the reason this works is we know just from our own intelligence, we're smart people, we know that if the age is not less than 12 or greater than or equal to 55, that it's greater than or equal to 12 and less than 55. So it kind of works that way. Let's take a look and see that we wind up with the same results. Remember, the if statements are commented out. They're ignored this time. So it's only using that trinary operator line this time through. So if we put in 7, we should get the 5.5. If we put in the 12, we should get 750. If we put in 49, we should get the 750. If we put in 55, we should get the 550. If we put in 77, we get the 550. Now, one of the things that this shows us is there's a certain amount of order of operations. The idea of precedence that we talked about in lecture 2, where we talked about how multiplication and division are performed before addition and subtraction, all operators of any kind work in a similar fashion. Comparisons take precedence over logical operators. So it will evaluate this as its own thing. It will evaluate this as its own thing before it does the logical operation. The logical operation takes precedence over the trinary operator, so it will check the truth of this entire piece before it checks which one of these to use. We're going to talk more about order of operations, operator precedence as we move forward. And on the midterm, there'll be a couple of questions that take that into account. One of the things I will tell you is, just like with mathematics, with these Boolean operations, comparisons, and logical, parentheses add a lot of readability and intentionality to what we see. So I will often add these other parentheses so that you see this whole thing is the first operand, this is the second operand, this is the third operand of the trinary operation, this whole thing is one operand, and this whole thing is another operand for the OR. Like I said, order of operations, the precedence doesn't require that, but we're going to use it in this case because it's very helpful. So what I've shown you is going to give you what you need for homework number 2. That will be posted, and then we're going to build on this example and do some things that are a little more complex in the next lecture when we look at looping, when we look at doing iterative operations where we do the same thing more than once. Again, you guys should have some familiarity with the idea of doing a loop, iterating through a certain set of code multiple times. We're going to go into some extra depth with that in the next lecture. But in the meantime, study this and work on the second homework assignment, and we'll see you later. Take care.